Hello and welcome to lesson 6, which is the third lesson of coordinate geometry, and today we're looking at the gradient of a line. So lines come in all different directions. You can have some straight up and down, you can have some on an angle, you can have some on an angle sliding down, or some straight across. Each of these straight lines has a measure of steepness. And today we're going to look at that measure of steepness and we're going to calculate it given two coordinates. So from, say, this coordinate A and this coordinate B. How steep is it from A to B? Well, let's think about this. Let's go back to our notation that we're used to, which is, if I just scroll down here, let's take point A to be 3, 6 and point B to be 5, 10. So we've got a line that goes here and we want to know how steep it is. Well, again, this goes back to almost to Pythagoras, but what we really want to know is just how far we have to go up for every step we go across. So to do that, we need to work out just how far across we're going and just how far up we're going. So just like when we were working out the distance of a line, we end up doing x2 minus x1, which in this case is 5 minus 3, which is 2, so we've ended up going 2 across. And here we do y2 minus y1, which is 10 minus 6, which gives us 4. Now that we've worked these out, well, what does that tell us? Well, the gradient, which in maths we use the symbol m, is equal to the change in y over the change in x, which in this case is the distance between y2 and y1 divided by the distance between x2 and x1. So in our example, the gradient, which is y2 minus y1 over x2 minus x1, will give us 4 over 2, which simplifies to 2. So this has a gradient of 2, this line. Now, I need you to just be careful with this notation. This notation, although it is exceedingly similar to something that we'll come on to later, which is dy by dx, this notation here, it means a large change in y over a large change in x, whereas this notation here means a small change in y over a small change in x. They are very similar, but when you come on to doing a bit of calculus later on, you'll see the deliberate difference in the two. So let's get a question for you to try. And here we have point A, and we're going to say that's 5 minus 3. And let's have point B, which is 7 minus 9. What would be the gradient of this line here? Okay, well, pause the video, unpause it when you're ready to start. Okay, so gradient, which is m, is given by the formula y2 minus y1 over x2 minus x1. So let's have a look. Let's call this one x1 and y1 and x2 and y2. So what have we got? Well, if we take the y's on the first, we get minus 9 minus minus 3. And we're going to divide that by 7 by x2 minus 5. So just be careful with your minuses here. You get minus 9 plus 3, which is minus 6. 7 take away 5 is 2, so my gradient here is minus 3 when you simplify that fraction. Now some of you may be wondering, does it matter which way round we call the x1s and x2s? Well, let's have a look. Let's pretend that actually what I've done is I've called this one x2, y2 and this one x1, y2. Does it make a difference? Still have the same formula, x2 minus x1, and let's have a look. Y2, in this case that's a 1, so y2 is minus 3, y1 is minus 9, and on the bottom we've got x2, which is 5 minus 7. So what does that give us? That's minus 3 plus 9 over minus 2, which gives us 6 over minus 2, which simplifies down to minus 3. So actually the order that we do them doesn't matter, just as long as my x's are together and my y's are together. So thank you for watching. That's the end of the lesson on gradients, and I hope it's been enlightening for you.